All right, so we're going to continue on in section 3.1, and we're going to talk again about something that's connected to our mean. We're going to talk about our standard deviation. Again, we're thinking symmetric distributions here. And actually, if we go back to the first video, the first thing that I mentioned is we talked about center and variability. So our mean is going to be like our center. It's our middle value. It's our average value. It's our typical value. Our variability has to do with how spread out our data is. So what we're going to use in order to do that for our symmetric distributions is use something called the standard deviation. So the standard deviation is a number that measures how far away the typical observation is from the mean. Right? So how spread out is that data value from our mean. Right, just like we did with our mean, we're going to start by visualizing it and talking about it in context. Right, so distributions with a small standard deviation have more observations near the mean. Distributions with a larger standard deviation have more observations far away from the mean. Right, so thinking about how we can represent this using pictures. Right, so the figures below show histograms for distributions of the same number of distributions, and all of the distributions have a mean value of about 3.5. Right, so if we look at all of these, in the middle we have a value of about 3.5. So the means are all pretty much the same, but our standard deviations are much different. Right? So we're going to answer two questions based on these histograms. Which distribution has the largest standard deviation, and which distribution has the smallest standard deviation? Right, so the one with the largest standard deviation is going to be image A. Right, and that's because if we look at our mean, we have low frequencies next to our mean. Right? So we don't have a lot of data values at the mean. We have a lot of data values at our extremes over here. Right? So we're going to say A has our largest standard deviation because it has the largest amount of observations furthest from the mean. Right. So our data is spread out. We have high frequencies far away from our mean. Here we have a uniform symmetric distribution, so it's kind of evenly spread out. If we look at this one, notice that our highest points are near our mean. So our largest frequencies are near our mean. Our lowest frequencies are far away from our mean. So in this case, right, the histogram that goes with image C, we're going to say it has the smallest standard deviation because it has the fewest number of observations furthest from the mean. So in general, what we're going to see if we're thinking about standard deviation, something with a smaller standard deviation is going to have more of our data in the middle. Something with a larger standard deviation is going to have high frequencies on our tails. Right, so what does this mean in context? Right, our standard deviation is a little bit more abstract than the mean. We say average, we have an idea of what we're talking about. But standard deviation, again, it's not necessarily as concrete and easy to pick out. So what we're going to think about in a symmetric unimodal distribution. So we're thinking symmetric with one mode. So we're thinking kind of something similar to histogram C in the previous example. Right? The majority of the observations, majority meaning about 2/3, are less than one standard deviation from the mean. So when we're thinking about our standard deviation in context, the majority of the observation, or about 2/3, are less than one standard deviation from the mean. And And we'll continue to explore this idea in some of the next examples as well.